Hi everyone, it's Valeria and I'm here to solve number 5 from the 2.3 homework assignment. So we're going to look at this equation and we're trying to find general form, the interval at the largest scale, and the transient terms. So first we're going to take a look at this equation and we're going to see whether it needs to be in general form. Right here we see that this is looked to be like it's already in general form, because if we take a look, we already have our p of x, we already have our function f of x, we have a leading dy over dx, and there is no coefficient here, so it is already in general form. So that's great. So now that it's at general form, we're going to look at our mu of x, which is our second step. Finding our mu of x, which is going to be the exponential interval 3x squared because of the px, which is going to equal the exponential x to the third power, just like so. And the reason for this is because when we take the interval, it's going to actually be e 3x squared. As so, and over here we have a special form of 1 which cancels out, which is why that's our mu of x. So now that we have our mu of x, we're going to multiply our mu of x, ex to the third power, by our general form, and the reason for this is because we're gonna check something out really quick to see if we're on the right track, which is something the professor taught us. So using FOIL method, we're going to distribute. So we're only going to take a look at the right-hand side. Sorry, I meant the left-hand side. So right here we have our function f, we have f prime, we have g prime and g, because if we take a look at e x to the third power, once derived, it's actually going to be 3ex to the third power x squared. So we are in the right path because we have our f, our g prime, f prime, and g. So once that's there, we're going to now take the interval of the right-hand side, and we're going to grab our mu of x times our y, and we're going to bring it down. And this one doesn't need to be, we don't need to find the interval for this one, and I'll tell you why. Because once we bring out the y prime and we take the interval, those are already canceled out. So once we take the interval for this, you should get 1, 3 ex to the third power plus c. So we have our ex to the third power y equals 1/3 ex to the third power plus c. So again, you guys can take the interval like on your own time. I'm just not doing it to save a little bit of time. But yeah, leave any questions down below if you have them. So now we're trying to isolate the y, so we're going to go ahead by dividing this out. Which is going to give us, and the reason for that is because these kind of cancel out, but it's still going to distribute to the c, which is why it's going to be like that. And I'm just basically bringing up the exponential by using the negative. But here once we have isolated the y, we have our general solution, which is great because that's what we were looking for. We were looking for a general solution and our general form. So now we found those. So now that we have that, we're looking for our transient terms, and we see that CE negative x to the third power is actually transient because it's the same as, oh, that's positive. And when an exponential is on the denominator, it actually goes to 0. So that is our transient term, because transient terms are the ones that cause you to get 0. So this would actually be a transient term, and it's our only transient term from the general solution. So now that we have that, we're going to look at the interval at the largest scale, which once drawn out, if you can put it in a Desmos or your graphing calculator, it's going to look something like so, maybe like that. And you're going to see that it's actually on the largest scale from negative infinity to positive infinity. So now we have our general form, which is up here. We have our interval at the largest scale, which is this. We have our general solution, and we have our transient terms. Let me know if there's any questions down below. Thank you.